Hello everyone. In this video, we will talk about functions in Python. So the idea of creating functions is that you can reuse your code like multiple times in the same file, or even in the future, if you want, you can create a library. So you can use one or multiple functions that you repeat several times in your different projects. So today we're going to learn how to create some basic functions, and then we will try to explore some useful functions in data science. So let's get started with the basics, how to create a function. So we need to define the name of the function, so it's def. So we provide a name. So I'm going to create something simple. So let's say that we're going to sum two numbers. So just assign a random name to just a representative name for the function. So I'm going to call it like sum2. Then you need to provide the parameters that are required for that function to work. So in this case, since you want to add two numbers, so we need two parameters. You can give any name to the parameter. So I will say just parameter 1 is A, parameter 2 is B. So I close the parentheses for the parameters. Then with the column, we have you can add multiple steps here. Since this is a basic function, you can just directly return the result. Or maybe you want to create like an intermediate step to say, okay, the total is just A plus B. Like the two parameters of the values. So when you're writing a function, you try to write it in a general way. So A and B, we're not using A and B. We don't know what is A and B, but the idea is that they represent the first value and the second value, even though they don't have, like an assigned value already. Okay, so once we have the total, then we return that value. Again, if you want, you can type directly return A plus B, and that will work. Just to be a little bit more formal, I want to show you that you have here one step or even multiple steps if you have a way more complex function. So let's see how it works. So when you run the function, it won't show anything. It's just, okay, we have created a function, but now you need to start using the function. So once it exists, so you can just use it, like, okay, sum2, then the two parameters, let's say 100 and 300. So we show the result, right? It's A plus B. So that's how you get the 400. All right, so it's simple in general to create a function in Python. Now let's create a different one. So here let's create a function to compute the mean and the variance. Let's do both, mean and variance. Okay, so first let's define the function. So I'm gonna call it mean variance. So what do we need here is the data, the numbers, right? It can be a list. Okay, then we need to show the steps. So let's do the mean value. So for the mean value, the idea is to sum the numbers, right? The numbers of the list, and then we divide that sum by the number of observations, right? So there is a method called len. So for an array, for a for a list, the len method is going to count how many items are in that list. So again, here numbers, it doesn't exist right now, but in the future, once you're using a function, you will provide that parameter, right? So it has to be a list with different values. So then you will use it, but in your function, you need to define, okay, how you're going to call that input, and then how you define how you use the function, how you use those inputs in your function. Okay, so we have the mean value. Similar idea with the variance. So we have the variance of the numbers. It's going to be equal to the sum you have to remember here the equation for the variance. So the equation for the variance, it's basically you have each value minus the mean that's to the power of 2, right? So we need to add them up. It's a sum of those values, and then we divide it by the number of observations. That's if that's the population variance. You also have the sample variance, so that will be divided by number of observations minus 1. So I'm going to assume here a population variance, but again, you can do, like whatever you need, if you need the population or the sample variance. Okay, so it's going to be the sum, the individual numbers. So here we need to iterate over the list with the of the numbers. So we're going to create here a comprehension. That's how you call it. So the idea is this is a for loop that I'm going to use here in order to do so. So it's num is just a variable that's going to take each value of the numbers minus the mean value, which was estimated in the previous line, right? That's what we did here in the previous line, in the previous step. So at this point, we assume that we have the value. So the difference square in Python square is times 2. But again, we have to use every single number in the list provided, right? So I need to use a for that num that we created. This is a general name that you can assign. It can be like just like I or J, but here it is for J in the list numbers. So basically, this num is going to take every single value of these numbers, right? So this value is going to be provided here. Then you get the difference, the difference square, plus then the second number, because this 4 is going to iterate over this list, right? So you get all the numbers, and you can add them up in the sum. So once we have the sum of every single difference to the power of 2, then we divide it by the number of observations. Again, this is a population variance, but if you have sample variance, it's minus 1. And finally, once we have completed our function, so we need to return the values, right? The mean b, that's how we call the mean value, and the variance of the numbers. That's it. So at this point, we have created our function. Now we can use it. So you can use it in the same chunk of code or in a different one. What's the difference? The difference is that if you do it in the same, so every single time you are going to create again the function, which is fine. It's only about it's only a matter of resources, and sometimes when you have a complex function, it may take longer. But in this case, it's a simple function, so it won't be an issue if you use the function in the same block. But let's do it here. So it's mean variance, and I'm gonna provide a list. You see the Colab AI is spoiling the problem every time, right? It's suggesting solutions. Most of the time, it's really accurate. You should use it a lot. So I'm just giving some random numbers. So in this, once I use this function, I will get two results: the mean value is the first one, and the variance, right? So yeah, we can test it. You can use numbers that you know the result, but here, for example, if I use the same number, so the mean has to be 5, and since there is no variability, the variance should be 0, right? So it's working. It's working. Great. That was our second function to compute the mean and the variance at the same time. Now, maybe you're thinking, okay, do I need to do the mean like this and the variance, or is it possible to use just the method that exists in pandas? Yes, you can use them. That's not a problem. You can use some methods or functions inside the function, so that's not a problem at all. You can create a function and then use that function in a second function. That's possible too. All right, so let's create one more. In this one, we want to perform some imputation. So what is the idea of imputation? Imagine that we have a data frame like this one with two columns, two variables, age and salary, but there are some missing values, right? Here in age we have 2 missing values, in salary there is 1 missing value. So in imputation, there are different approaches. So one is this is a basic one, just to fill the values with the mean value, right? So compute the mean of the variable or the column, and then replace the 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 values, the empty values with the mean value. That's just one way to do it. There are other more elegant ways to do the imputation. For example, in some cases, if the variable that you're trying to change, it's a, let's say, a numerical variable, maybe you can do a regression model to predict, like the value. Or in other cases, you will see with categorical variables, maybe you will use something like based on other observations that are similar to that observation that is missing some values. So it's like k and n, like the k nearest neighbors. So you find k observations that look really similar, and then you will pick the median value or the mode depending on the type of variable. All right. So in this function is simple. It's just we're going to replace the missing values with the mean, and that's it. All right. So let's create a function. The name, I'm going to call it mean imputation, and the main input here is we need the data frame and the column name. So which column you want to perform the imputation. You can do it for all of them if you want. That's fine. But in this case, let's say that in your function, the one that we're creating, the user has to specify the column name. All right. So once we have the column name and the data frame, we need to find the mean value. So you can use the previous function. The only thing is that you have to be careful because it's giving two values, right? So you need to pick the mean, not the variance. Or you can just compute it using existing functions or methods. So we have here the data frame is the first parameter, right? Then the column name is the second parameter. And we apply the mean value. And then once we have the mean value, we just replace the empty value of the NAs using the mean. So in data frame, for that column that was specified, we're going to replace it. How? So it's just def, again, name of the column. And there is a method called fill NA. So let's say that you have like several NAs in a column. So you can assign a value to the NA. It can be 0, but in this case we want to fill those values with the mean value that we found here in the previous step. So let's do that. It's just fill NA. With the mean value. And then we return the data frame. So we save. And here we have a sample data set. In this one we have empty values, you see? This NaN in both variables, in age and salary. Here we create a data frame with that dictionary. But now let's perform the mean imputation in the age column. So remember the name of the function, just when you want to use it, mean imputation. The name of the data frame is df, right, this one. And then in which column you want to perform the imputation. So let's say the age column. So now in the age column, you notice there are no empty values, right? Because we're replacing the two values using the mean. There were two values originally, again, but now, since we're using the function, we're able to replace them using the mean. That was the whole purpose of the function that we created. So it's working. You can do the same for the salary, and then you will get, you know, like something different in this one. You will get the mean value of the column. Okay, let's do one more. This will be our last function in this video. So in this one, we want to standardize a data frame. So what is the idea of standardization? Sometimes when you're computing some, let's say, when you do clustering, k-means, which is a very popular algorithm in clustering. So you need to measure some distances between observations. So you need to ensure that all variables, they are in the same scale. Because right now, for example, age is between, let's say, 0 to 100 typically, but the salary, it's in a different scale, different units. So this is like 50,000, 100,000 or more. Then if you try to compute distances between observations, they have different variables, different units, that will be a mess. So you need to ensure that they are in similar units, same scale. So in order to do so, standardization is one way to do that. So pretty much what you do is, like, for each variable you compute the mean, and for each value you subtract that mean and you divide it over the standard deviation. So what you get when you standardize, it's basically that observation where it's located in terms of the mean and the standard deviation. So for example, if it's 0, it means that the value is equal to the mean value. But let's say that the observation is equal to 1, that means that that value is above the mean by 1 standard deviation. If it's -2, for example, then the interpretation is that specific value, it's 2 times below, 2 standard deviations below the mean value. So that's how you do the interpretation of when you standardize your data. So that I'm pretty sure that in your statistics courses, when you were working with the normal distribution, it's quite popular to use the standard normal distribution, where you compute z values, right? To use the z table. So let's do that. Let's create a function to standardize our variables. Okay, so let's assign a name. So let's define our function. The idea is to standardize the data frame using the same name. That's fine. The parameter here is the data frame. Okay, now we define the steps. So we're going to create a copy of the data frame to use it. And now, since you need to standardize per column, because you might have multiple columns in your data frame, I'm gonna use a for loop in order to, you know, like iterating to standardizing each column, each variable. So for column, or I can call it call, that's the name that you want to assign, doesn't matter. In, so how do we get the columns in total, the list of columns? So when you have a data frame, let's say here in the previous example, let me add here, I'm sorry for the zoom, is difficult for me. Okay, now it's working. Let's say I have a data frame that already exists, df. I think it exists, right? So if I use the attribute df.columns, I get a list with the name of the columns. So please note that I'm getting the list here, right? Age and salary. So I can access the names of the columns using this attribute, right? So that's what I'm going to do here. So for column in df columns, remember that df is going to be the parameter, that's the input of my function. So you're taking that data frame dot columns, so this is going to be a list with the name of the columns, the name of the variables. So I'm going to take this column is just a variable that we created, and I'm going to take each element of the df dot columns. So that means that it's going to take the name of the variables. So once we do that for each of the columns, the idea is to compute the mean. The AI is already giving us the answer. That's fine. So the mean value is going to be data frame, that specific column, the mean, then the standard deviation. Same idea, data frame, column, but now we use STD, standard deviation, right? And once we have the mean value and the standard deviation, we can standardize that column. So the new value is going to be equal. So it's the original value minus the mean divided by the standard deviation. So let's do the operations. It's the original values is in the df in the data frame column. That's the column that we're using. Remember, we're iterating in the loop. So we subtract the mean value, and then we divide this by the standard deviation. Okay, so now we get the standard values once we have standardized. So once this is completed, let's just return the standardized data frame. All right. So we can create this. It exists now. So using this data, look at the original data. We have age and salary, and we want to standardize these values. So the data frame exists with these two columns. Now let's standardize the data set using our function. The name is standardized data frame. So let's call the function. So it's going to be standardized data frame. It exists here, and we're going to provide the df, right? This data frame that we just created. And here we're getting an error. So let's find the error. Let's see what might be creating the problem here in our results. So let's check the name of the error. It says name column is not defined here. It's showing the error. Oh, so look at my for. It's important. I mean, I'm gonna leave this in the videos because it is important to debug our codes. You know, like to fix them. So it's important always when you get an error. Sometimes the message is pretty big, so you should start, you know, like at the last part of the error. That's where you get the description, and then you see, okay, the description is that the name column is not defined, and then it shows the problem, right? So if you notice in the for, I'm using a different name for column. I mean, that was a mistake here. I used call moon instead of column, right? So of course, then it's not recognizing what I'm doing here. It's an error, of course. So I'm gonna fix it. So it's column, right? So now it should match. So now when I run it, now it works, right? The problem was just with the name. Okay. So now instead of getting the original data set, remember with the age, for example, 38, 30, 35, 40, 44, 45, and the salary is between 50,000 and 90,000. Please notice that we get numbers that are like, you know, like negative numbers, positive numbers, but most of them are between -3 and 3. So the interpretation, again, for example, let me take this one, the third observation, the third row. So the age of this individual, it's, for example, the age, it's below the mean value by 0.46 standard deviations, and the salary is right, is the mean value. It's exactly the mean value, right? That's the interpretation of these results. Okay, so in this video we talk about how to create functions. We create 3 4 functions, and even we fix a problem here, a small problem that was just a typo that I made. So I hope that you will be able to create more functions in your code in the future. And I'm pretty sure that you will enjoy it, because it's at the beginning when you create your functions, you feel proud of it. It's like you feel really cool when you create your first function. So I hope you enjoy now your functions in your future code. So I'll see you in the next video. Have fun.